And welcome to the On Maths prediction for the OCR Foundation GCSE Maths Paper 1 for May 2018. Enjoy! Hi and welcome to this On Maths prediction. So what we're going to do in this prediction is go through a predicted paper for the upcoming exam. Now what we mean by predicted paper is what we've done is gone back through the two exams that have already been sat for this, June and November last year, and we've picked out topics we think will come up again, and we've also picked out topics that didn't come up again. We've also looked through all the literature released by the exam board so that we can have a look at what they're hinting at will come up. And they've dropped some hints so far about certain aspects of this paper, which we've picked up on and put into this predicted paper. Now, this is, I think, the third year we've been doing predicted papers, and I say this every single year, and I hope that people are listening, which they clearly are, I hope. This predicted paper is not a be-all and end-all. Please don't use this as this is my one thing I'm going to do for the exam. I don't think anyone does, but I'm going to say this anyway. Use this as a revision strategy, just like you'd use a revision guide and anything else. It's a good way of just testing how your revision's going. And what a lot of people last year did was they did the test, had a go at it, see what they got, and then did the test a couple of weeks later to see if they've raised their grade. And just regularly doing the assessment will help you judge kind of what grade you're at. Now we construct these papers so that they're balanced by topic. So it's the example would say what percentage of each topic should be on the paper. We also balance them by assessment objective, basically difficulty of question. So they're balanced between AO1, AO2, AO3. If you know what that is, then brilliant. If not, don't worry about it. They're also balanced about grade. So the example would say roughly how much of each grade. They give it categories, but they're balanced along those. So it's an accurate paper in that regard. There are some questions that involve drawing and things like that we can't do perfectly, but hopefully we do it in a way that you definitely know how you'd use a compass or a protractor if you were asked to do that physically on paper. Now, those of you who've done predictions with us before would know that this entire paper is available on our website completely for free for you to try, and you can do it online. You can even register to save your scores, so you can have a go at the paper, come back a week later and remember what you got and see if you can beat your score. The website and this video will keep track of the grades as we go on, and on the website it shows you what grade you're at so far, and the difference between what your grade is and the maximum amount you could have got on the paper so far. So it's a really good tool to kind of judge what you need to do to get a grade 4, 5, 6, 7, 8, 9, whatever grade that you're looking for. The website also includes loads of other stuff. I'm not going to be able to go into all of it, but we've got topic busters are the main ones, which is every single topic at the new GCSE, and you can just go through and practice any topic you like. We've also got demon questions, which are the hardest exam paper questions. I was talking about assessment objectives earlier. These are AO3, which is the hardest ones. They're problem-solving questions generally, and they're the ones that students struggle with the most. So we've got demon questions that you can just practice the hardest ones. Now, obviously, there's lots and lots and lots more on the site, so please check the site out after you've watched this video. We also have a supporters club, which comes with a few extra perks. Obviously, everything on the site is for free, but one of the perks we're looking at including, and probably have by the time you watch this video, is a PDF download of some of the papers, including this paper. So if you want to consider supporting us, please check the link that's probably come above my head right now. So if you like this video, please click like. If you don't, obviously click unlike, and please consider subscribing. We're going to release the paper 2 and 3 papers just after paper 1 for paper 2 and just after paper 2 for paper 3. Those are more accurate predictions because obviously we can take off the topics that have already come up. I hope you enjoy this video. Thank you. When we're asked to write a number in figures, it just means as numbers. So we've got 5,026. We need a 0 there as a placeholder. So you're just going to write 5026, 5026. Next question says, write down the value of 8. Now, if we remember, and let's just write the number a little bit bigger, this is our units column, this is our tenths column, and this is our hundredths column. So the value of the 8 is 8 hundredths. We can write that as a fraction, 8 hundredths. And that's the answer. Question C, write down 655 correct to the nearest 10. Okay, so 655, if we just do a quick number line, 655, the next 10 up is 660, and the next one down is 650. So those are the two it can round to. This 655 is bang on halfway, and if they are halfway, they round upwards. So the answer is 660. If I draw that properly. If it was any less, if it was 654, it would round down. So if the last number, if that number there is 5 or more, it will round up. On this scale on the side of the jug, we're not given the little tiny notches. So the word estimate means that we're not going to get it exactly right maybe, but we're roughly going to be correct. Now there are wrong answers to this. So if I wrote the answer 22, which would be down here somewhere, that's clearly wrong because we know that the water is above 30. We know the water's between 30 and 40. And if you have a look, it's less than halfway. So we're expecting a number that's below 35. I think if you wrote the number 35, you would get that wrong because it's clearly less than halfway. I think the numbers, probably to get it right, you might get away with 34, but definitely 33 or 32. I think, personally, it's closer to 33, but some of you might look at that and think it's closer to 32, and chances are we'll both get the marks. You will need to be familiar with the names of three-dimensional shapes. So the one we have here is a triangular based prism. So a prism is a shape that you can cut anywhere along one of the axes, so anywhere along here, and it would look exactly the same. It would look like a triangle. The first bit of this, triangular based, is just the name of the shape at the end, the name of the shape at the end of the prism. So you can have a hexagonal based prism or anything like that. It says write down the number of faces. So the faces we can see, well, the face we can see here is a triangle, so that's one. Then we've got one along here, which is a rectangle. So we've got two that we can see, but there is also going to be a third one round here, which is also going to be a rectangle, a fourth one at the bottom, which is going to be a rectangle, and then a fifth one round the back, which is going to be a triangle, just like number 1. So in total there are 5 faces. Try and remember what a face is. A face is something you can lay your hand down flat on. An edge is something that you can run your finger along, so that's an edge there. And vertices, or vertex, is something that if you put your finger on, it would be pointy. So there are going to be 6 vertices. So it asks for an even cube number. So the cube numbers are 1 cubed is 1 times 1 times 1, which is 1. The problem is that is an odd number, so let's try 2 cubed. Now 2 cubed is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 8 is an even cube number. Now you could have also had 64, which is 4 cubed. 6 cubed is above 100, so that would not count. So 8 or 64 are the correct answers. So this question asks us to write the smallest odd number. Now there's 2 instructions there. We need to make the smallest number from the digits, and it needs to be odd. So to make the smallest number, we want to use the smallest digits on the left hand side of the number and the largest digits on the right hand side of the number. Okay. We also need the last number to be odd. Now to make a number odd, the last number needs to be 1, 3, 5, 7 or 9. Okay, so looking at the largest numbers, the largest number is 6, so we want to end on a 6. However, 6 is an even number, therefore if we end on a 6, it will be an even number. So we've got to look at the largest odd number, which is the 5. So the 5 is going to go here to make the number odd. Then we need to use up that 6 next. And then the next largest number is the 4, and then 3. So my answer is 3,465. Now always just check to see whether we've answered the question. It said it wants the smallest odd number. Well, that's an odd number, and I can't think of a way of swapping those digits to make it any smaller, because we've used the smallest numbers we can on the left hand side and the biggest on the right hand side. For this question, we need to understand the difference between multiples and factors. Multiples are just a numbers times table, so the multiples of 5 will be 5, 10, 15, 20, etc, etc. Now every number in the 5 times table ends in 0 or 5. So looking at the list of numbers we've got here, there's only one that ends in a 5 or a 0, which is 10. So 10 is a multiple of 5. Now factors go the other way. A factor of a number means that the number, so 24, is in another numbers times table. So 24, and the easiest way to find the factors of 24 is you start off with 1 and 24, because 1 times 24 is 24. Then you go 2 times, 12, 3 times 8, 4 times, and you think how many 4s? 6. 5 times, well that doesn't work. 6 times we've already got. So those 8 numbers are the factors of 24. Then I look at the list, well, already there's a 24 there. Is there any other ones I could have written? I don't see any other ones, so 24 is my answer there. 2 prime numbers. Now prime numbers mean they only have 2 factors, 1 and themselves. Okay, that's a prime number. If there's any more factors, it's not a prime number. So let's go through the list. 10 is in the 5 times table, which we identified in question A, so that's not a prime number. 24, well, we've listed out 6 other factors of 24, so that's not in it. 18 is 3 times 6, so that's not going to be it. 17, I don't think of any times tables that 17 is in, so I'm going to say 17 is a prime number, which it is. And 19, well, I can't think of any times tables 19 is in, so I think that's a prime number. Let's go through the rest to make sure. So 16 is 2 and 8, so that's not a prime number. And any even number apart from 2 is not going to be a prime number. 2 is the only even prime number. 27 looks like it might be, but actually 3 times 9 is 27, so it's definitely not. And 28 is another even number. So it looks like we found the 2 prime numbers. Okay, so this question is about coordinates, and the biggest mistakes with coordinates is getting them the wrong way around. So point A, which is this one here, it's either going to be 2, 1 or 1, 2. And the way of remembering it is you always go across first and then up. You go along the corridor, up the stairs. Okay, so you always read off the x-axis and then the y-axis. So the coordinate is 2 because we go 2 to the right from the middle, and 1 because we go 1 up. Now coordinate B is the same, so we're going along the corridor to -2, and then up 3. So along 2, or we'll go to the left 2, and up 3. Okay, it's asked us for which coordinate is at a point -2, -3. So we're going across to -2 again. But this time we're going -3, which means down 3. So it's going to be coordinate C, because C is at -2, -3. Okay, so we're asked which 2 points on the line y equals -2. So we've got to understand what y equals -2 is first. Y equals -2 is a line where y is always -2. Well, we know y is -2 here, but also y is -2 here, and actually anywhere across this line. And we call that line y equals -2 because y is always -2 along it. If you have a y equals line, it'll always go from left to right. If you have an x equals line, it'll always go from top to bottom. So the two coordinates on that line are D and E. So the 2 points on the line are D and E. So for this question we're asked to find the percentage of the shape that's shaded. So there are 4 sections in total and 2 of them are shaded. So as a fraction that would be 2/4. Well, we can halve top and bottom, so it's a half. And you can see there that half of that's shaded. So what is half as a percentage? Well, a whole as a percentage is 100%. So a half as a percentage is 50%. And if you didn't know that, you need to just practice knowing the main percentages. A tenth is 10%, a hundredth is 1%, and a quarter is 25%. Okay, the next question says what fraction is shaded. So we need to know 2 things. First of all, how many squares are shaded. So 1, 2, 3. So it'd be 3 over the total amount of squares. So there's 1, 2, 3, 4, 5, 6, 7, 8 squares. So the fraction is 3/8. For the next question, it says shade in a fifth of this shape. Well, there's 10 squares altogether, and we want to shade a fifth. So we need to find a fifth of 10. In other words, what's a fifth times 10? When you times something by a fraction, just divide it by the bottom of the fraction. So another way of writing that is 10 divided by 5, which is 2. A different way of thinking about this question is if you cut this shape up into 5 equal sections, those sections, the green sections, become a fifth. So if we want to shade 1/5, we just want to shade in one of those sections. And actually that's the amount of squares that our calculation just worked out. So it should be 2 squares. Now, it doesn't have to be the 2 squares that I've shaded. As long as you've shaded in 2 squares, then you've answered the question. And the last question says, write down the fractions there that are equivalent to a quarter. Well, a nice easy way of starting this question off is just write down things that are equivalent to a quarter. So what I'm going to do is I'm going to times top and bottom of this fraction by 2. So 2/8. So I've times them by 2. Then I'm going to times them by 3. So it would be 3/12. Then I'm going to times them both by 4, and I'm just looking at this original fraction here. I'm going to times them both by 4, so it would be 4/16. And times them both by 5, 5/20. Now all those fractions are equivalent, which means the same as a quarter. So let's have a look at our list. Well, we've got 2/8 there, so it's that one, and we've got 5/20 there. So my answer is going to be fraction B and fraction C. And the place I'd start with this question, since we're going to be asked for the median anyway, is just to put these in order of sides, and that will help us work out the mode and range. You don't have to do it, it's much easier to spot. So the smallest number's 38. Is there another 38? No. The next number's 39. I think there's a few 39s. Okay, the next number's 41. I'm crossing them out as I go so I don't count them twice accidentally. So 42, 43, 44. Now the mode means most. Okay, if you just remember that, mode most is pretty much the same word. So what came up the most? Well, if you have a look, there are 3 39s there, and there's 2 42s, 2 41s. So 39 came up the most. And it's much easier to spot when they're all lined up. The range is the biggest, take away smallest. And again, this is a lot easier when they're all lined up. So it's 44, which is the biggest, take away the smallest, which is 38. Now, I know that you can do this in your head, but use your calculator anyway. Why not? Because this is a calculator question, but we know the answer is going to be 6. Okay, so the median. Now the median is the one that you've got to find the middle one, so it's the middle when in order. And I put that in capitals because most people forget that one who get this question wrong. You have to put them in order of size first, okay? And what you do is you cross out one from both sides, then another one from both sides, then another one from both sides, then another, until you're left with 1 or 2 in the middle. Now if you're left with 2 in the middle, then you add them together and halve it. Or find the number that's halfway between the two. Now if they're both 41, the median will be 41. If you think about it, 41 times 2 is 82, and then halve it, it's going to be 41. Now the mean is, a lot of people call it the mean one. You add them all together and divide it by how many? So I'm going to do this on my calculator. I'm going to do 38 plus 39 plus 39 plus 39 plus 41 plus 41 plus 42 plus 42 plus 43 plus 44. Hopefully I've got the right answer of 408. Over how many there are? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need to divide that by 10, and I get 40.8 for the mean. Now, I would always double check that, so I'm going to do it again on my calculator, because when you're typing a whole load of numbers, it's always easy to make a mistake, but it's very rare to make the same mistake twice, and it's come up with 408 again, so I know it's probably right. Okay, so this question is basically asking you to find 9% of 16,750. Now, because it's on the calculator paper, there's a much easier way to do it using the calculator. Without a calculator, you'd work out 1%, and then you times that by 9, or work out 5% and 4% and add them together. But with a calculator, you just need to know that percent means per 100. So 9% is the same as 9 over 100. Of just means times, and so all we need to do on the calculator is do 9 over 100, so fraction button, 9 over 100, times 16,750. And that gives us the answer of 1,507.5. So in money, that is £1,507.50. The easiest way to order decimals is just to put yourself a few columns down the page, and hopefully I'm going to try and get enough columns. I always end up with not enough, so if I put some extra ones in, that should suffice. And just literally put the numbers in, so 14.828, and make sure the decimal points are lined up, so 8.60 is going to be like this, and I'm going to put an extra 0 in to make them all the same length. It doesn't change the number at all, so 14.86, I'm going to put 0 in there, 14.820, and then 14.7. Now we're starting with the smallest, so I'm looking for the smallest one first. Well, the smallest one's leaping out, because if I just look at this column, there's only one number that has a 0 there, all the rest of them have 1. So the 8.60, and I have to put the 0 because that's how it's said in the question, is definitely the smallest. So we can cross that out. That's definitely the smallest. All the other ones are tied. They're all 1 in that column. So we move over to the next column, the next one to the right. So 4, 4, 4, 4, they're all tied. So I keep moving along. Okay, there's a clear loser in this one. There's a clear one that's the smallest in this one. The bottom one, 14.7. So that's definitely the next smallest. so I can cross that one out. All the other 3 have tied because they're all 8, so I move on to the next column. Now, looking at this, there's 2 2s and a 6. Now that 6 is definitely the biggest number, so I could fill that in as the biggest number. And we've just got to work out what the smaller of these remaining 2 are. Well, let's move on a column. And you can see here that 14.82 is the smallest or smaller of the 2. And so that leaves the 14.828 in that position. Now always just double check the 5 numbers you've listed are the same as in the question. That's the same. 18.60, that's the same. 14.86, that's the same. 14.82 is the same, and 14.7 is the same. You sometimes lose a mark if you haven't written exactly the same number. Same goes for when there's fractions and decimals. You've got to write down the number that it showed in the question. Okay, so in this question we see that a square has an area of 121 centimeters squared, and we're asked for the perimeter of the square. So the first thing I would do is do a quick little diagram of this square, and we know that the area is 121 centimeters squared. Okay, so I know it's a square, so therefore the width, or the base, and the height will be exactly the same. Okay, and I know to find area I do this one times this one. So I know that x times x, or x squared, equals 121. And if I put my lines in, then I can square root both sides, and so x is 11. So I know that 11 times 11 is 121. Now the temptation is to think, right, I've got the answer 11. But it's asked for the perimeter of the square. So I know perimeter is the distance around the square, and each side is 11. So it's 11 plus 11 plus 11 plus 11, or 11 times 4, which is the perimeter, which is 44. So the answer is 44 centimeters. So the first thing to look at in this question is how many sides has the spinner got? So we've got 1, 2, 3, 4 equally sized, equally spaced out sides of that spinner. So any one of those colours is going to be a quarter chance. So let's have a look. What letter on the probability line represents a probability the spinner will land on a yellow? So there is 1 yellow on that spinner, and so therefore it's going to be a quarter chance. So if you have a look at how many notches this number line has, well, we don't count the first one, so we've got 1, 2, 3, 4 notches. So each one of those notches is going to be a quarter. So 1 quarter will be at B. Which letter represents probability of landing on a red? So we have 2 reds there. So that's going to be 2 quarters. So we've got 1 quarter and 2 quarters would be at C. Now 2 quarters is the same as a half, which is what the 0.5 there is. It's just a half. What letter on the probability line represents a probability it will land on a blue? Well, there aren't any blues on there. So however many times you spin it, it will never land on a blue. And in probability, we mark that with a 0. So it's going to be A. Okay, so the numbers in this question seem a bit daunting, but the process is always the same with this type of question in ratios. The first thing you've got to realise is, are you given a total amount, or are you given an amount of food or amount of drink? It says in total they spend that amount, so it's a total amount. So step 1 is to work out how many parts you have altogether. So for food it's 39. And for drink it's 4. And this will be a calculator question, so why not use the calculator even though we can do it in our head. 43 parts. So we've got 43 parts. The next stage of this is to work out what 1 part is worth. So 1 part is worth how much? Well, you get the amount and you divide it by the number of parts. You're splitting the amount of money between 43 parts. So 11911 divided by 43. And I get £277. So each one part is worth £277. Now let's read the question. Find how much money is spent on drink. Well, drink is this one here. And the order which they are in the question, food, drink, is the order which the ratios are. So food, then drink here. So there are 4 parts. So we're just going to write drink. So if each one part's worth 277, we're just going to do 4 lots of that. And I might as well do it on the calculator, times by 4. And that's going to be 1108, so 1108. When solving, always just write out the question and put down lines either side of the equals. And what we're looking at doing is doing something to both sides so that we get x on its own. So we want to end up with x equals at the bottom. That's when we know we've solved it. So looking at the left hand side, we need to get rid of this 6 here and the take away 6 there. Now we must remove the plus or the minus first, as long as it's not trapped in a bracket or a fraction. So we're going to get rid of the minus 6. To do that, we need to do the opposite of it. So we need to add 6 to both sides. So we're going to end up with 6x on the left hand side, because we've got rid of the minus 6. And we're going to add 6 to that to make 60. Now we want to get rid of the 6 before the x. Now that's a times 6. When you put a number next to a letter, it's a times. So to get rid of it, we need to divide 6. So we're going to end up with x on the left hand side, and 60 divided by 6 is 10. So the answer is x equals 10. Didn't need that much room in the end, and that's it. With two-way tables, we've got to use the totals to work out the missing numbers. So a nice place to start is this box here. If we have a look, we've got a total of 46 people with brown eyes. 23 of them are female. So all you need to do is 46 and take away the 23, and that leaves 23 left over. Now let's have a look at a nice easy one. Right, green eyes, that's a nice easy one there. We've got 48 in total, and 27 females with green eyes. So we want to do 48, take away 27, and that leaves us with 21. Now if we have a look at this one, we have 23 females 23 males with brown eyes, 18 males with blue eyes, and 21 males with green eyes. And we assume that there weren't any others because they're not in the table. So we add those together and that gives us 62 in total. And let's have a look at this one maybe. So we've got 62 females altogether, and we've got 27 of them have green eyes and 23 of them have brown eyes. So we take the 23 and the 27 away from 62, and that leaves us with 12. And we can just check that. We can do 23 plus 12 plus 27, and it equals 62. So we know that's right. With that one sorted, we can get this one. And if there's 18 males with blue eyes and 12 females with blue eyes, that means there's going to be 30 altogether. Now this total is either the total of these ones or the total of these ones, and they should give you the same number. Don't add the blue and the green ones together, so it's only one of them. So 46 plus 30 plus 48 is 124. And let's just check that. 62 plus 62 is also 124. So don't ever write down 248 because that's not correct. So in total there are 124 people whose eye colour were checked. Okay, so this is quite a tricky question because it mixes fractions and ratios together, but we've got to be comfortable with that. So I'd first of all just show the information so that I can get my head around it. So we've got Denver, who as a fraction has 3/19 of the food. And so that leaves how much? Well, we've got a calculator, so we could just do 1 take away 3/19 on the calculator, but we know that that's going to be 16/19. So we can kind of ignore Denver now because we used Denver's amount or fraction of the food to work out Engels and Fido's combined. So that's how much food they'll get, but they're sharing it in the ratio of 5:2. So in total, the amount of parts they have is 5 plus 2, which is 7. So there's 7 parts altogether. Okay, and each part, so one part is going to be worth, well, as a fraction, it's 16/19 divided by 7. So 16/19 on the calculator divided by 7, which gives us 16/133. So that's the fraction of each part. Now it says, show what is Fido's share. So we're looking for Fido's share. Now Fido gets 2 lots of that. So looking for Fido, he gets 2 lots of that fraction. So I'm going to times that by 2 on the calculator, which is 32/133. Now it does say show your answer as a percentage rounded to the nearest percent. So to work between fractions and percentages, I just need to times by 100. So what I can do is just times that by 100. I'll do it on the calculator, times by 100, and press S to D if it comes up as a fraction. And it says 24.060 blah blah blah. So to the nearest percent, Fido gets 24%. Okay, so the first thing to realise with this question is what perimeter means. Perimeter is the distance around a shape. Now we've got a lot of x's and numbers, but it does say it wants an expression for the perimeter. So we're not looking for a number as an answer, we're looking for an expression, so letters and numbers. Okay, so there are a few sides missing, so I'm going to try and find out this side first. And to get this side, we're going to add the 5x here with the x there. So 5x plus x is 6x. So we've got that one. Now, if the total distance across is 7x plus 16, and the bit we know is 6x plus 11, then the bit we don't know we'll have to add up together to make the 7x plus 16. So we need another x and we need another 5. Okay, we've labelled all the sides. So what I'm going to do is pick a point on the shape, and I'm just going to start walking around the shape and writing down everything as I go. So perimeter equals, and we've got 6x plus 11 plus 5x plus x plus 5 plus 6x plus 7x plus 16 plus x. So we've got quite a lengthy string of algebra there. Now we'll always need to simplify this. Okay, so if I collect the x's first, so we've got a 6x plus a 5x plus an x plus 6x plus 7x plus an x, which is going to be 26x. Okay, let's do the numbers next. So we've got 11 plus 5 plus 16, which is going to be 32. Okay, so the perimeter is going to be 26x plus 32. Now, a different way I could have done this is just focused on this one and doubled them. Now let's have a look and see how that works. If this length here is 6x, then these two here would add together to make 6x. So in total we have 12x going down. All the ones going across is going to be double this one. So it's all going to add together to make 14x plus 32. And then if you add those together, that would also give us the 26x plus 32. Make sure that you know the names of the parts of the circles. So a diameter is a line that just goes across a circle going through the centre. If it doesn't go through the centre but it goes across the circle, it's a chord. A bit of a circumference is the whole way around the circle. A bit of a circumference is called an arc. And there's a few more parts of a circle you need to know. Now, on this question, there's a line which touches the circle just at one point, and it's a straight line. The name for that is tangent. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got two decagons, and so that means they are 10-sided. And you can just count the sides if you want, but if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out one and then double it. And then take that away from 360 to work out A. And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got two exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. So you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first, since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19. And then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator's set to a mode which is going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to two significant figures. Now, to do two significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in your answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0. And actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400. Okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. So, inequalities, what are they? They just mean instead of x equaling something, x is greater than or smaller than something. So, x can normally have lots of different values. Now, this statement here is really important. Integer just means a whole number. So we know that x can't be a half, because that's not a whole number. Now, x says here, x is greater than minus 7 and is less than or equal to 3. So when it asks you to write down all the numbers that's true for, well, let's have a think. Well, if it's greater than minus 7, then it can't be minus 7. It can't be equal to it. So it's going to be minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, and 2. Now let's have a look at the other one. It says x can be less than or equal to 3. So that line there, if you look at it, that little line there, so if I do it a little bit bigger, the line that I've just drawn there says it can be 3. So we must include 3 in our answer. And that's how you get full marks. Now you probably will get 1 mark if you forget to put the 3 down or you put the minus 7 accidentally. Right, the next one I'm just going to write out a little bit bigger. Now the way we do this question is the same way as solving just a normal equation with an equals, but don't ever put an equals. There was an exam a few years ago that if you wrote an equals in it, they would give you 0 marks. So the first step is to expand the brackets. So I do smiles and rainbows, but if you've got another method, that's fine. I'll put a little line there to remind me to times it. So 5 times 3x is 15x. And 5 times minus 5 is minus 25. Now, you could have divided both sides by 5 and that would have been fine. Next step is to get rid of this minus 25. And you must start with that. You can't get rid of the 15 first. So we're going to add 25 to both sides to get rid of that minus 25. So we're left with 15x on this side, and 35 plus 25 will be, well, 5 plus 35 is 40, 40 plus 20 is 60. Now to get rid of this times 15, we need to divide both sides by 15. So that will get rid of the 15 there. And how many 15s in 60? Well, 2 times 15 is 30, so it would be 4. Now be really careful not to accidentally put any equal signs in your answer, and especially this bit here. So it's x is greater than 4. First thing we need to realise with this question is, which transformation is it? Well, you have to go through the 4 transformations. The first one I think of is, has it rotated? Has it spun around? No, it hasn't. Second one, is there a mirror image of it? No, they both look the same, so it's not been reflected. Has it grown or shrunk at all? No, so it's not an enlargement. So that leaves transformation. Translation. Translation. Now translation just means we've moved it, and that's perfect because we have just moved A to B. Now the second thing to realise is we are starting at shape A and we're going to shape B. Now with translations, to describe them, pick the same point on both shapes. I always pick the top left if it's available. Then what we want to do is work out how far left or right I have to go from A to get in line with B. And I do this with jumps, and the reason we do this with jumps is I never get the wrong answer when I do jumps. So 1, 2, I need to go 2 left, so 2 left, and let's have a think, how much up do we have to go? So 1 jump, 2, 3, 4, so 4 up. Now the way of showing translations is by using vectors, and it sounds fancy, but it's just putting this information here between a bracket. The number at the top of the bracket is how far right it's gone, and the number at the bottom is how far up it's gone. Well, let's do the number at the bottom first. So translation by, there's different words you could use there, and the number at the bottom, well, it's gone 4 up, so it's just a 4 there. Now here's a problem. This is how far right it's gone, but it's gone 2 left. Well, we just simply put -2 right. Now be careful, don't ever put a fraction line between the -2 and 4. It's not a fraction, okay? So don't ever put the fraction line in. Okay, so this question's about an adult and 2 children. So we've got David Smith and 2 children. So there's 1 adult and 2 children. But the prices shown are not quite right because there's a discount. There's a 5th off adult price and 30% off the child price. So let's work out the adult price first. So a 5th off. Well, first of all, let's work out a 5th of £70. So to work out a 5th, you can just divide 70 by 5. Now I know that 10 fives are 50 and 4 fives are 20, so that's going to be 14. So that's going to be £14 he gets off, so therefore the price will be the £70 take away the £14. So 70 take away 10 is 60, take away 4 is 56. So he's going to pay £56 himself. Let's do the child price. Okay, so it's 30% off the child price. So we want to do 30% of £37. Okay, let's do the equals down here to give us some room. Well, I know that 10% is going to be £3.70, and then I need to times that by 3. Okay, so I could just times it by 3. Let's have a think. I could do 370. I could do it in pence, and then just times that by 3. So 370, and then I can just do times 3. So I can do a little grid. And if this is on the calculator, then obviously you just type it into the calculator. And obviously that's going to be 0, so we don't need that one. So that's 900, that's 21 with a 0. So 900 plus 21, 210 even. 0, 1, and then 11. So that's going to be £11.10. And so we want to work out the price. So it's going to be £37, take away £11.10. So if you take away 10 it's 27, take away 1 is 26, take away 10 is £25.90. Now that's for one child, so that's one child. So if I want 2 children, I want to do £25.90 times 2. Now I know 25 times 2 is 50, 90 times 2 is £1.80, so that's going to be £51.80. Okay, I'll move down a bit and let's do the total. So the total is going to be the adult price, which is this one here, plus the 2 children price, which is that one there. So I want to do 56 plus £51.80. And again, if you've got a calculator, you can just type it in, but let's do the column method. £1.80, and then people like putting the zeros in. So that's going to be 0, 8, 7, 10. So that's going to be £107.80. So it's £107.80. Finished. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. For these types of questions, always make sure that you show your working. Show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these two are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding because they won't accept any other word. So I can solve this by first of all adding 50 to both sides. So that's 2y equals 102, and then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51. degrees. Now I know that this is 52 degrees because if you look at this, I'll use a different colour, this angle here and this angle here are Z angles or alternate angles. Or you can say that this 52 degrees here is equal to this here, which is also 52, because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103. And therefore, that's going to be 77 degrees. So my answer is 77 degrees. So this question says there's a tennis tournament being played where each player plays each other once. And there's multiple ways of doing this. One of the ways is listing out all the different combinations. But this question only asks for how many tennis matches are being played. So you don't need to list them out, and sometimes you will need to list them out. This one you don't. So let's start off with a liar. A liar has 4 people that they're going to play against. William, Paul, Samantha and Christine. William, well, we've already counted a liar's match with William, so William only has 3 left that he can play. Then Paul we've already counted his match with the other 2, so he's only going to play Samantha and Christine, other than his matches we've already counted. Samantha, well, Samantha's only got Christine left to play after we counted all the other matches. And Christine, well, Christine's matches have already been counted so far. So, we've got the 4 matches a liar's going to play, the 3 matches that William's going to play, not counting the one we've already counted from a liar, plus the 2 Paul's going to play, plus the other one that Samantha's going to play. So 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So in total there are 10 different matches going to be played. Okay, there's more than one way to expand and simplify a single bracket. You're essentially doing the same thing, but some of you might want to draw grids or do it in a different way. I always just use smiles and rainbows, so I just create a smile between the 2 and the 3x, and a rainbow between the 2 and the 6, and I put a little time sign there to remind me to times it. Just put a notch through the bracket. That means we're going to times 2 and 3x, and 2 times 3 is 6. And then we've got the x there, and 2 times 6 we're going to times together to make 12. Now we've still got the 4x, so I still need to write that down. Then I'm going to collect like terms. Now the like terms we have is the 6x and the plus 4x. So 6x plus 4x is 10x, and then there's nothing that we can do with the 12, so we just leave that. So it's 10x plus 12. Okay, the next one, there's a double smiles and rainbows. We've got one here, put a little time sign there, and we've got one here. So we'll do the first one first. So 8 times 6x, so we do 8 times 6, which is 48, and then we've got the x. Then we do 8 times positive 2, which is 16, so plus 16. Now that's nice and easy. However, the next one's slightly different. The number outside the brackets is not a 3, it's a minus 3. So when we do minus 3 times positive 4x, we're going to get a negative, because a minus times a positive is a negative. Then we do 3 times 4, which is 12, and then we've got the x as well. Now the rainbow is -3 times -5. Two minuses times together is a plus. 3 times 5 is 15. Then we look for like terms, so we've got the 48x and the -12x, and we've got the +16 and the +15. So we want to do 48 take away 12, or 48x take away 12x. So if we take away 2, it's 6. If we take away 10, it's 36x. Then we want to do 16 plus 15. Well, 15 plus 15 is 30, so that's going to be 31. So the answer is going to be 36x plus 31. Now the most common mistakes are for that n bit there, this bit here. Sometimes students will write down -15. Okay, this question looks quite confusing because it says the weight of the sack is 19 kilograms, but then it asks you for the smallest and largest possible weight that it could be. So it seems quite confusing at first until we realise that it is rounded to the nearest kilogram. So the first diagram I draw out is just a line, and I put 19 in the middle. And I think to myself, right, what was the next one down that it could have been? If it wasn't 19, if it was less, what's the next one down it could have been? Well, the next one down would be 18. And then I think, well, what's the next one up it could be? Well, it could have been 20. It's not 18 or 20, it's 19. And then I think, well, what's the cutoff point between 18 and 19? So I draw a line down here, and the cutoff point would have been 18.5. So if it was 18.4, it would have been rounded to 18, but 18.5 or more, it's rounded to 19. And I do the same on the other side. So I draw a line between here and here, and this time I think, right, what's the cutoff point for this one? Well, that's 19.5. Now, this second one's a little bit more complicated because you might think, oh, actually 19.5 would round to 20. So it's 19.49 recurring. Yes, you would actually be true. Unfortunately, 19.49 recurring is actually the same as 19.5. So for our smallest possible weight, we put 18.5. And for the maximum possible weight, we can actually put 19.5, even though we know that would have rounded to 20. Now this works because it's a continuous scale. If you were doing an amount of counters, say if it was 19 counters, or I don't know, 190 counters to the nearest 10, then the lowest one would be 185, that would be fine. But the highest it could have been before it was rounded to the nearest 10 would be 194, because you can't get like a 0.1 of a counter. So just be wary of that if you're working in discrete calculations, so things that can't be 0.00001 or something, then you do 4 at the end of it for the maximum. But if you're working with heights, weights, things like that, then 19.5 for this one is absolutely correct. Okay, for Venn diagrams, it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18, or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and. And it means it needs to be in A and B. It can't just be in A, it can't just be in B, it needs to be in both. And there's two numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are two numbers that fit that bill, so that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1/4, or a quarter. Okay, so this question, it looks like a standard bearings question, but something you might notice is there's no angles in it. So if there's no angles in it, we need something else, and that something else is going to involve the right angled triangle here. So we can see there's a right angled triangle here, and we know that when we've got right angled triangle, we've got two sides, we can find an angle with trigonometry. I'm going to call this angle x. Now to find x, we need trigonometry, and to do trigonometry, we need to label the sides. So we've got the opposite here, which is opposite the angle we want. We've got the adjacent here, and we've got the hypotenuse here. Well, the hypotenuse is no interest. We're not looking for it, and we're not given it. So it's O and A. So writing SOHCAHTOA, SOHCAHTOA. Well, we're not interested in the H, so it's not going to be SO, and it's not going to be Ka, so it's going to be TOA. So TOA stands for tan x equals opposite over adjacent, and the opposite is 47, and the adjacent is 72. Now we want to work out what x is, so to do that we want to inverse tan both sides. Okay, let's just scroll down. Okay, so on the calculator you want to click shift or the equivalent on your calculator and then tan, and then you press the fraction button, 47, and go down, 72. Just don't forget to close the brackets. Every time you click tan or inverse tan, it opens a set of brackets. Just make sure you shut them. Let's press equals, and that equals 33.1356, blah, blah, blah. Okay, let's have a look. So x is 33, but we still haven't got a bearing. What we can do is work out what this one is, and I'm going to call that y. So to work out what y is, it's going to be 33.1. Well, we're looking for nearest whole number, so let's call that 33. And then we're going to add the right angle here. Now, the reason I know this is a right angle here is because it says that he heads west and then south. So I know that both the angle here and the angle here are going to be right angles, because the angle between all four, north, east, south and west, all four directions are going to be right angles. So I'm going to add 90. And you can do this in the calculator, or you can do it in your head. I'm going to do it on the calculator. 123. Okay, now bearings, something that we've got to remember, are always from north going clockwise. So it's always going to be like that. It's going to be that angle there. So to do that, we're going to do 360. We're going to take away the 123 because that's what we don't want. So on a calculator, 360, take away 123, and that's 237. So the answer is 237 degrees. Okay, so question A is about reverse percentages. So in 2014 and 2015, well, let's have a look. So the sales went down between the two. So if we start off with 100%, and they went down 12%, what we're left with 88%. Now, as a multiplier, and this is the best way of doing this, 88% divided by 100, make it a decimal, is 0.88. Now that number 0.88 is what we times the 2014 sales to get 2015. But in this question we're given the 2015 sales, so we're given this one here. So we want to work backwards. So what we want to do is I'll get my calculator, 7,359 divided by 0.88, and that gives me £8,362.50. You've got to ask yourself, well, is that reasonable? Well, they went down by 12%, so it's natural that they would go from a number around just over 8,000 to a number that's just over 7,000. So I'm going to write the answer, £8,362.50. Okay, and the next question says that the sales went up in 2016, or they have a target to get their sales up in 2016. What's the percentage increase? Now, percentage increase or percentage decrease, it's the same formula, is change over original times 100. So the change, well, that's going to be 12272, take away the 2015 sales, so that's that one there, 7359. So they're looking for it to change by 4,913. The original was at 7,359, and we need to times by 100. So I'm going to divide that by 7,359, times it by 100. And that gives me 66.7617, blah, blah, blah. So that's to the nearest percent, so that's going to be 67%. Whenever we see a 3D shape in a question, you've got to ask yourself, is the question asking for a volume or a surface area? And that should be the first question that goes into your mind. Yes, it might be asking for something else, but those are the main two. We're looking at this, we're filling the swimming pool with water, so it's going to be a volume question. Now, way of approaching this is figure out what the shape is. Well, the shape is a trapezium-based prism. So we've got to first of all work out what the area of the trapezium is. So I'm going to draw the trapezium out first. And that height is going to be 2.7 that side, 5.3 that side, and 25 across. And I'll leave off meters because I know they're all in meters, but do check they are all in meters when you do this. So we've got to first of all work out the area. Now the area of a trapezium is half A plus B H. Now A and B are always the two parallel sides, and then the height is the one that connects them at right angles. So the height is going to be 25 there. And all you're doing is working out the average of the two bases, the 2.7 and the 5.3. We're going to times that by 25. Okay, so we'll crack our calculator out. 2.7. Some of you will probably see this straight away. So the first bit comes out as 4, because halfway between 2.7 and 5.3 is 4, and then times 25 is going to be 100. So the area is 100 meters squared. Now, for a prism, so volume, all you need to do is work out the area of the cross section, which is this bit here, the bit we just worked out, and then times it by how 3D it is. I think they call that the length officially, 15 meters. So the volume is going to be 100 meters squared times 15, which is going to be 1,500 meters cubed. So that's what the volume is, and it says the machine transports the water at a rate of 20 meters cubed per minute. So in 1 minute it's going to be 20, in 2 minutes 40. The other way of working this out, or the other way of thinking about this, is how many 20s are there in 1,500? So we can say time equals So this is how much it's got to fill, and this is how much it does per minute. So on the calculator, 1,500 divided by 20, which equals 75 minutes. So it's going to take 75 minutes to fill the pool. I hope you enjoyed that video. If you like what you see, please click subscribe, and then you'll get notified on all the content we put out. Also, check out our YouTube channel. We've got all the topics in the Maths GCSE collated by grades, by topic, by tier. We're finding that it's really useful resource. I think we've got hundreds and hundreds of videos. They're tiny little videos on each tiny little topic, which students are finding useful. Don't forget to check out the website as well. Everything on the website, all the online papers, everything we put out on the website is completely free. And also don't forget, if you really like what you see and you want to support the site, please click this link now above me, and that will take you to the supporters club. Thank you very much.